All right, friends. Thanks for tuning in and watching the video. You're working on this kind of on your own while the rest of the class is doing their map testing. And what's cool is it's going to be a review from last year. We're reviewing some one-step equations. And so as you're doing equations, I want you to keep the goal in mind. The goal is to isolate the variable. And what that means is we need to get the variable by itself. Pretty much there's a missing piece. We want to know what that missing piece is. And we want our answer to say something like, our missing piece is this. So I'm going to be a little picky on how you hand these in, because I think you can probably look at these and get an answer, but we're going to work on the strategy of doing inverse operations and showing the inverse operation you're doing, because in a few days we're going to be doing a lot of steps with our equations, and when we do a lot of steps, you won't be able to just look at it and get an answer. You'll need to use this strategy. So a lot of times I call it it's like training wheels. It's kind of easy to do, but eventually we have to take them off, so we're going to practice doing it the right way. So I have 4 questions here. What I suggest you do is I'll do the first couple, or maybe just the first one, and then you can pause the video, and I think it's good practice for you to then try the other ones and then make sure it matches up with what I'm doing. So like see what I do, get an idea, and then go try them out and then push play and see if it's the same answers and in the same method. So, sorry about that. Announcements just came on. Anyway, also, if something seems a little fast, it's YouTube, bro. Just rewind it, okay? So, I'm looking at this equation, and what I'm saying in my head is I want to get m alone. So, goal, m equals number. That's my goal. My answer needs to be m equals number. So, I'm looking at this plus 12 right here, and I'm like, you got to get out of there, man. I'm trying to get m alone. So how do I get rid of plus 12? Well, I subtract 12. And then you'll know from your hanger diagram activity you did on Desmos, if I do it to one side to keep my equation balanced and equal, the only way it's equal is if I do it to the other side. Right? So if I take 12 away from here, I have to take 12 away from over there. What that ends up giving me is m equals -2. I found the missing thing. What's cool is you can check your answers by substitution. If m is -2, -2 plus 12 equals 10. Did it. All right. Number 2, we got to get g alone, okay? So I need to get rid of this -9. How do I get rid of -9? I add 9 to it. Makes it 0, right? See you. Sometimes I like to imagine karate chopping that 9. Hiya! I cut it off, man. Now we're left. Now this is a thing you don't have to do it like this, but you probably should. I write my variable on the left and my value that's left on the right. And that's a communication thing. The whole point of this equation, right, left equals right, g equals 7 is the same thing as 7 equals g. But in terms of communication, I'm trying to figure out what g is. So my answer says g equals 7, all right? So it's like, it doesn't change your answer being right or wrong, but it's just better communication. We've talked about that a lot this year. So looking at number 3, I got to get rid of this dastardly number, -7. So how do I get rid of times -7? I divide by -7. If I divide one side by -7, I have to divide both sides by -7. And that gives me a 13. Remember, we can always check our answers by substitution. -7 times 13 better equal -91, otherwise I mess something up. Also, there's a lot of stuff going on in work. I want to point out I'm boxing answers. That helps my eyes go to it when I'm done, okay? All right, number 4. I've got to divide by 9. How am I going to undo dividing by 9? Multiply by 9. If I multiply one side by 9, I need to multiply the other side by 9 to get my -36. All right, so I know a lot of us can just look at this and get the answers, but this is the process we need to use, because eventually we will not be able to do this. You'll be doing 10-steppers. And so how do you do a 10-stepper? You go step by step and show exactly what you do. Math is communication, right? That's what this is. That's all this is communication. All right, so let's look at some other one-steppers here. We have some fractions. Now, fractions are no big deal, okay? The same method applies. I'm looking at this and I'm saying, how do I get rid of it? So the top one here, I have a 2/3 times x. Well, how do I undo times 2/3 to get x alone? Well, the answer is we would divide by 2/3, right? 2/3 divided by 2/3 is 1. It's gone, because 1 times x is x. Now, you might remember, though, if we wanted to divide by 2/3, what we've been doing is switching to multiplication and multiplying by the reciprocal, right? So I'm not actually going to use that. I'm going to use the same principle, but I'm going to multiply by the reciprocal because that's the same thing as dividing by itself, right? We know anything divided by itself is 1. Check out what happens when I cross-simplify everything. It equals 1. It's the same thing, right? So it's the same thing, but we're going to want to use that multiplication. So on this top one, instead of writing divide by 2/3, I'm going to write times 3/2. That is divide by 2/3. And then if I do it to one side, I have to do it to the other. All right? So when I'm multiplying fractions, I could do top times top, bottom times bottom, but I'm going to choose to cross-simplify here first. These both have a factor of 2, and that gives me an answer of 15, right? This is why it's so good to have that fraction stuff on point from Unit 1. So looking at the second problem, I need to get rid of times -6/5. So I want to divide by -6/5. But with fractions, when we divide, we multiply by the reciprocal. So I'm going to multiply by -5/6. Now it's important that you take care of the negative here. If you don't multiply by a -5/6, we'd be left with a negative x. We want this to be negative times negative equals positive because I want a 1. Because 1 times x is x. Right? So if I multiply that left side by -5/6, I need to multiply the right side by -5/6. These cancel each other to be 1, and 1 times x is just x. And when I multiply on my right side here, 6 and 12 both have a factor of 6. I can simplify first. You don't have to. The difference is you'd have a 60 divided by 6 instead of a 2 times -5. Either way, you get the same answer, -10. So big picture here is, we still do get rid of multiplication by division. Just keep in mind when we divide by a fraction, we actually end up multiplying by the reciprocal. It's going to save you some work. I've seen some students do work like this, where they divide by 2/3 and divide by 2/3, which is fine. But then their next step, they need to do something like 10 times 3/2 still to change the divide by 2/3 into multiplication. And I just think it's more work and more clunky. Just multiply by the reciprocal. That's the same thing as dividing, and it's just cleaner and tighter. All right? So you're going to practice some of this. There's a Go formative for you to do. It'll tell you if you're right or wrong. Really important. Answers need to be letter equals number. Letter equals number to get it to show up green, that dot for you. Work really hard, and we'll see you in the next class after there's map testing. So be good.